Alright, so we're now starting on 3.4. Now in 3.4, I could use the book. They have some examples, but I think I like these better. I'm just going to go ahead. I can teach this a little faster over your videos, not so long. Okay, so there's two parts of 3.4. Okay, there is function operations, and then second part is compositions. So first we're going to do function operations, and we're actually going to use these same four functions. So if you want to follow along, stop for a second, copy these four functions down. Okay, so when we talk about function operations, so we have four different functions. All of these are functions: two quadratic, a linear, and a square root function. All of them pass vertical line test. Okay, so as we're going to look at all these, and what we can do is we can do operations. When we talk about operations, we're talking about add, subtract, multiply, and divide. Okay, so as we talk about those, we do want to deal with a few things as we deal with them. Okay, so if we look at these two problems, okay, or these multiple problems, we're going to show how we're going to do these operations. So when we look at operations, there are a couple ways they can write these. Okay, what we're going to do is we're going to find the answer to the operation and then state its ending domain. We'll talk about the domain secondary. So you might see a function operation like this. This means f minus g of x. This would be f of x minus g of x. These mean the same thing. I tend to see most people find this one a little easier. So if you see it in this form, you can write it in this form. It makes it a little easier. Okay, so you've copied these down. Okay, if you haven't, go ahead and stop the tape again and make sure you copy those down so you can kind of follow along, because I'm going to be moving this around. Okay, so we're going to first find g of x minus h of x, which is just basically we're going to take g of x and subtract h of x. Okay, so g of x being negative 2x squared minus everything that's in h of x. And notice the parentheses that I did. Okay, so as we do that, that parentheses is going to become important because that minus sign is going to have to go through. So the only thing I can do in adding and subtracting is combine like terms. Okay, that's something you know, that's a prerequisite you're supposed to have. So the only thing that can be combined are these two. So this is going to be negative 2x minus, or negative 2x squared minus x squared, which would be negative 3x squared. But then this negative is going to go through here, negative 3x, and then the negative with the negative 4 is going to make it positive 4x. And so that is what happens when you subtract g of x minus h of x. You get that. Okay. Now, what about domain? Okay. Domain is what x can only be and nothing that x can't be. Remember our rules. Okay, our rules for domain, when we look at our domain look-fors, we talked about that before. Our domain look-fors, okay, something in a radical or an x in the denominator. If it doesn't have any of those, it's all real numbers. So if we look here, no square root, no variable in the denominator, so my domain is all real numbers. Done. Okay, so now what we're going to do is we're going to go ahead and add f of x plus h of x. So f of x, 2x plus 3, plus x squared plus 3x minus 4. Now if you notice here that I still did the parentheses, but when I distribute the plus sign, it's not going to change any signs. So I'm going to combine like terms, which would be x squared plus 5x, and then negative 3 minus 4 is negative 1. So there is my answer to the addition, and the domain again would be all real numbers because there is no square root and no x in the bottom. Okay? Now, I was going to say I might throw a different one more answer here in a minute, but we'll see in a second. It'll be on another section. So let's look at this one. F of x times g of x. And we may write it f times g of x. That's another way you write it. Okay, so we're going to multiply f of x times g of x. So f of x times g of x, and basically we're just going to distribute. So we're going to get negative 4x cubed minus 6x squared. And again, no denominators, no square roots. It's all real numbers. Okay. Now, I realize I didn't have one in here, so let's look at this one, f divided by g of x. In other words, f of x divided by g of x. Okay, so we're going to have f of x divided by g of x. Alright, so that's all we can do. There's no reducing that. There's nothing I can reduce out of that. So that answer would be right. So what would my domain be? Well, then here we have this right here. That we have to worry about domain right here. X on the bottom. Well, when I have x on the bottom, we're only looking for things that would make it 0 on the bottom. Well, what would make this whole thing 0? Well, x is not allowed to be 0. So my domain is going to be everything except 0. So we would write it as negative infinity to 0, union 0 to infinity. That would be my domain. Okay? Now, what happens if they don't have an x and they have a number? Well, that's going to be simply f of negative 2 plus g of negative 2. Oops. Really don't need that one right there. Hate messing up. Alright, so how do I find f of negative 2? We plug negative 2 into the function. So the f function is this. Remember we did this before. Everywhere I see an x, I'm going to put a parentheses, and we're going to put a negative 2 there. And in the g of x, negative 2 times x squared, and we're going to put a negative 2 there. And then we're going to simplify. So that's going to be negative 4 plus 3 plus, that's 4, negative 8. So that's going to be negative 1 plus a negative 9. It'll be negative 9. So my final answer is negative 9. There's no domain in that problem. You're not going to worry about domain in problems like here. Okay, no domain in that type of problem. Okay? So, just as FYI, we just want to be able to locate that kind of stuff. Okay? Now, the other part of 3.4 is what's known as compositions. Okay? Notice I have the same 4, so you don't have to recopy a whole bunch of different functions. I'm going to use the same 4 functions. Okay? Now, in these, basically, if necessary, we're going to do the domain. That's only going to come with problems that have an x in it. So this will have a domain, and this one's going to have a domain. Okay? If it has a number that they put in it, no domain issues. Okay? So, what is a composition? A composition is when you take a function and put it into another function. Okay? So, when we look at it, it's going to be written 2 different ways. G of f of x, okay, with this little circle here. It's the same as what's known as g of f of x, and they write it as g of f of x. Okay? And basically you're going to work it inside out. You're going to put the f function into the g function. Okay? Well, what does that mean if there's a number there? Okay? Well, if there's a number, okay, like this one, 2, you're going to first find f of 2. Okay? So, once you find f of 2, so we're going to do that, 2 times 2 plus 3, which would be 4 plus 3, which is 7. And then you're going to take that answer and put it into the outside function, which is the g function. So you're going to find g of 7. And in g of 7, that's negative 2 times 7 squared, which would be 49 times negative 2, which would be negative, let's see, 49 times 2, 96, 98, excuse me. So I get negative 98. Okay, so let's look at another one just similar to it. This is h of k of 4. So the first thing you do is you're going to find k of 4. Well, k is that square root. So it's going to be the square root of 4, which is 2. And then you're going to take that 2 and put it in the h function. And in the h function, it's 2 squared plus 3 times 2 minus 4. Okay, so that's going to be 4 plus 6 minus 4, so 4 plus 6 is 10, minus 4 is 6. So the final answer of that composition is 6. Okay? Now I did put a little thing in here, k of -4 is not possible. Why is it not possible? Because if I put it into the square root, remember square root would have given me 2i. It's not possible whenever you get an I in your final answer. Okay? So, let's look at what if there's not a number. F of g of x again. Okay? So we're going to look at f of g of x. Okay? So, f of g of x, which would be f of g of x, which would mean we're going to take the g function and put it in the f function. Well, if you remember, the f function is 2x plus 3. The g function is -2x squared. So what we have to do is, everywhere we see an x in the f function, we put a parentheses, and we're going to take the g function and put it into that. And then we're going to simplify. Okay? So as we simplify, we're going to put, this would be -4x squared plus 3. And there is my f of g of x. And then its domain would be all real numbers because there's no look-fors there. Okay? Now, what if I want to find g of f of x? Would that give me the same answer or a different answer? Well, that would be g of f of x, which would mean in the g function, we're going to put f of x. So there's the x value for the g function, -2x squared, and this is my f of x right here. Now, what does that mean I have to do? Well, that means I have to square this. This is going to be 2x plus 3 times 2x plus 3. And you'd have to FOIL it, or however you want to look at it. It would give me 4x squared plus 6x plus 6x plus 9, which would be 4x squared plus 12x plus 9, and then we still have to multiply the -2 to all that. And it's going to give us -8x squared minus 24x minus 18. And domain of that? Well, no square roots and nothing on the bottom, so -infinity to infinity. Okay? So just want to let you look at those and how they differ. Okay? But notice, did I get this same answers or different answers? Right? I get different answers. A lot of time, most of the time, a great deal number of times, the reverse of these will not be the same answer. Okay? They are not commutative. Okay? So I just want you to be aware they are not commutative. Okay? So let's do one more. And I haven't done one with a domain that would involve with the square root. So let's do one more. Let's do f of k of x, which would mean I'm going to take the f function, 2x plus 3. There's my f function. And I'm going to put the k function inside. There's the k function, which would give me 2 times the square root of x plus 3. Because all I can do is distribute that. Now, what would be my domain if I have a square root? Okay? Now this would apply to the other section too. Remember, this has to be a positive number, correct? So, as long as x is positive, we're going to be fine. Okay? So, x has to be positive. So x has to be greater than or equal to 0. So in this case, x has to be 0 to infinity. Okay? Because x has to be a positive number. It cannot be a negative number. It can be 0, but it cannot be a negative number. And so that's why I can only use x values that are positive in that problem. Otherwise it would not work. Okay? I know I went kind of fast with some of that stuff, but that's why we have the videotape. You can stop, rewind a little bit, and redo things as you catch through them. Okay? And that would be my suggestion for you.